Hi everyone, this is a quick tutorial on how to do site models in Rhino. So last time we've imported a DWG drawing into our Rhino file, which has all the contour lines, all the building components, etc. It was called point resolution site. We'll click open. It's going to bring this thing in. I'm just going to double click on the viewport to zoom in. And what we noticed was that it's composed of 3 large blocks. And on the bottom left hand side, there are a lot of curves, some block instances and some text bits. And for the purposes of this exercise, I'm going to concentrate on this and here. So what I'm going to do is I'm going to just delete these 3 blocks. Another thing that we noticed is that it's quite small. So if I measure a distance of this road, let's say, it's fairly small. So last time what we did is we actually scaled this 1,000 times. Another thing I realized, if we go into options, we can actually change the unit sizes under annotations, units, change it from millimeters to meters. That provides a very quick, without scaling of course, provides a very quick solution to this problem. So now if we measure the distance of this road, it'll be within reasonable scale. Another problem that we noticed is if we draw a line, let's say, and start at the origin. So the way you do that is when you draw a line, it asks you for the start of the line, and you can actually put in Cartesian coordinates to tell it where it needs to start. And as we can see here, it's quite far away from where the model is. So, oops, I'm just going to bring myself back to where I was by holding Control A, then going zoom, selected. So what I'm going to do is I'm going to move this point here to the origin. So I'm going to select everything, click on M, enter, select this point, and it asks me for the point to move to. I'm going to choose origin point again, and again I'm going to click on zoom, selected, and it's going to bring this model essentially to the origin, well, closer to the origin. And the reason why I want to do that is because sometimes when you're modeling too far away from the point of origin, some glitches might occur, some inaccuracies, so you might want to avoid that. So here we have our model closer to the origin. Here as we see the construction plane is visible. If it is not visible, you can go into options, and under grid you can actually change these properties here. So you can make it bigger, you can make it smaller, or visible at least, and press OK. Another thing that people have noticed is whenever I select something, it selects in this purple color, or whatever color was on before. You can actually change that in options. If you go into options again, type in options, it's under appearance. So under Rhino options, under appearance, there's a tab called colors, and over here we have a whole bunch of options that basically change the whole appearance of the viewport tab. So in this particular case, we're looking at selected objects. If we double click on this rectangle, we can actually change the selection color to anything we want. And the reason why I changed that is because I think by default it was yellow. Whenever you select yellow objects and its selection color is yellow, you can't actually see it, so that becomes a bit of a problem. So you might want to change that if you wish. Now, the last thing in this preparation of importing DXF files into Rhino is the layer structure. So if we go into this layer tab, or we tap in layer, it will bring up this tab here. It will show us what's inside this layer structure of this document. And as we can see, there's a whole bunch of layers that are actually not labeled properly. So we don't actually know what they are. So we're gonna have to rectify this problem. And in my case, I'm going to create a couple of new layers, and whenever you create a new layer, by usually clicking this button, you name them. So there's buildings, there are roads, and the way you name them is so they are descriptive. So you know what you're looking for once you've assigned things to them, once you turn them off, once you lock them. So you know what objects are on each layer. So you want it to make it as descriptive as you possibly can. So there's contours, minor, there's contours, there's major contours, there are green areas, which are grass, well, bushes and trees essentially, and did I say buildings? For everything else, well, there's water line, so I'm going to put that in, and I'm also going to put in other for all the other stuff. And now whenever we click on layers, so for instance, let's click on this yellow line. If we select properties tab, we can actually, under layer tab, we can see which layer it's on. So it's on level 30. So if we find level 30 in here, we can actually, if we click on name, it'll sort them out alphabetically and numerically. Level 30 right there. Okay, so we can right click on that and go select objects. So it'll select all of the objects that are on this level, layer, and we can go back to the layer that we've created, and so I want to assign it to the minor layer, so I right click on that and go change object layer. So now if I hide it or I go select objects, it will select all of these objects. Another way of doing this is you can select this by color, because these are neatly organized by color, if you don't want to fish for them in this massive list of things, and that becomes quite handy. So because we can select an object of a particular color, in this instance green, and we can go to select color and it'll select all the objects of the same color. So now all we need to do is go back to this layer that I want to put it on, in this case green, and I can go change object layer, and now this object is on a different layer. I can do the same thing for roads as well. I'm just going to change these to this layer. At the moment, so they're kind of all over the map, but we're going to fix that. And I'm going to change this one as well. Select color, and this one I think was called the waterline. Change object layer, hide. Now hopefully the buildings, I'm not sure what the building, which layer they're on, level 7. Let's have a look, level 7, select objects. Okay, so these are, looks like these are buildings, because they kind of mix together with text, parcels, and fences and things. And looks like retaining walls as well. So I'm just going to go ahead and put it on the building layer. I'll just hide that, and maybe put everything else on the other layer. So now I actually can tell where my objects are just based on these names. Now, of course, we have this problem of having all these other layers that are now empty because we took objects from them and put them on our layers. So if we want to get rid of empty layers, I mean, we could go through and delete them all individually. Quicker way is to run a purge command. Now a purge command gets rid of all the bad objects in your file, also gets rid of all the layers that are that don't have any objects on them, just to make sure that the boolean layer is set to yes, and we can go okay. And as you can see here, it actually gotten rid of most of our layers except for these ones. And the reason why it hasn't gotten rid of these ones is because they have blocks on them. And I mean, we could go through and delete blocks or explode them. Something that I'm not going to worry about now, but you can do all of these things through Block Manager. So if you go into Block Manager, it will show you all of these blocks here that are present in these files. Most of these are text objects by the looks of things, but there are some large chunks of geometry. And what blocks are just collections of geometry that have been put into one container. Okay, so if you want to move layers around, because I kind of want to move these down, you can use these arrows here to kind of put them close to each other because I kind of want to cluster them. So I'm just going to work with these layers. I mean, I guess I could get rid of the blocks. Let's say block manager, and I could select. I mean, that is if you want to get rid of all the, I mean, you could explode them or export them. I'm just going to delete all of these. So I can then delete all of these. Okay, so now it's neatened up a little bit. I think I'm going to move default upper stack. Okay, so we've got our buildings, we've got our green areas, we've got our waterline. Okay, so one thing we've noticed with the waterline is that I tried to, let's hide our buildings first. Okay, buildings are selected, so I'm going to select default layer, deselect the buildings, and select the waterline level. Okay, so what I try to do is I try to join this line together, join enter, but it looks like it only joined certain parts of it. So here we have two sections that are not joined together, and so you might not be able to tell straight away what's going on, but if we zoom in a little bit, we'll see that they're not actually touching, the ends are not touching. In these kinds of situations, these curves will not be able to be joined together. Now here they'll look like they're touching, but in fact if we go into side view, select the viewport and go zoom enter, select, zoom in here, and we'll see, so I'm looking at this intersection here, they're not actually touching because the ends do not meet in the z-axis. So there's a couple of ways you can deal with this problem. I think, well, the quickest way is probably just to project all of this onto this construction plane. So the way we do that, the way we could do that is we can select these curves. Notice this bump here as well. So this is not only not touching in XY plane, but it's also not touching in any vertical plane. Anyway, so we've selected this. Make sure that the top viewport is selected, and we type in project to C plane. We'll go yes, and notice how now this is flat. So we'll go join. The majority of this portion is joined now. Now here it's not joined because they're not touching each other in the XY plane. But if we select roads here, what we actually notice is that there is a bit here, which is essentially a what looks like a boat ramp, and I'm going to assume that the waterline kind of goes around it. So I'm going to select sorry, not roads, waterline as my current layer, and I'm going to select polyline, and I'm just going to draw around it. Make sure my object snaps are on. So I'm snapping to things, and as you can see, what I did there is it snapped to this object, right? So now this curve here is not planar, so I need to project it back to the construction plane and join everything together. So it creates a nice kind of complete curve here. Okay, so that's that. So now I think we're ready to start modeling the site. Looks like I've got rid of major contours, but not sure why. So I might just rename these to contours. If you double click on the name, you can actually rename these. Okay, so now that I have the contours, what I want to do is I just want to model a small portion of the site. And the reason for that is I don't want to deal with a lot of geometry. I just want a very simple parcel to deal with, and I think I'm just going to go with this little area here. And what I'm going to do is I'm going to draw a 3-point rectangle just around this area, and this is what my site model is going to be. It's just going to be this, and just taking a little bit of this water here. And the first thing I'm going to do is I need to separate these contours from the rest of the contours. So if I go into my perspective viewport, what I can do is, first thing is to extrude this to act as a reference. And maybe, okay, we need to change the viewport setting. So if we right click on this viewport tab and change it from wireframe to shaded, you can actually see 3D objects in as shaded objects. And now what we can do is we could split our small area contours from the rest of the contours and use this box as a splitting mask. And now when we select these contours, we see that it only selects this portion, which is great. So we probably don't need this box anymore. Just going to select all of this stuff. I'm going to type in invert. It's going to invert everything that wasn't selected, and just type in hide, and it will hide it. So maximize perspective now, and we see that it's a neat set of contours. Now the little problem that I noticed is that the first and second contours are slightly different to the rest of the offsetting, because this should be 1000 millimeters and moving up, but here they look a little bit it looks a little bit odd, and I'm not quite sure why that is. Just gonna try to measure this, I guess, and to figure out what's going on. So yeah, that's 1000 meters, and this is 1.29. So if it was 2, I was kind of hoping this would be 2, so I can just move this in the middle, but it looks like it's a little bit more complicated. So what I'm going to assume is that these two contours are water lines, and that the water, well, depending on the time of the year, it will be between these two contours. So when I'm modeling my topography, I'll try to make sure that it hits water somewhere between these two curves, somewhere in that area. Before we do that, I'm going to create a surface that is going to be a reference for our water, actually. So we know that this rectangle is flat. What we can do is we can run planar surface, and it's going to create a flat surface through these curves, and that's going to be our water. Now we're going to run a patch command through these curves. Before we do that, we're going to need points, because patch command takes in points. So we're going to extract points from these curves first, and we're going to run extract point commands, this one here. It's going to extract the points that these curves are made out of. In this case, they're polylines. So you see for every kink there is a point, and by default it also selects these points. So now what we could do is we could run a patch command, and we see this little menu pop up, and you can actually change all of these numbers, and when you click preview, it's going to show you what has actually changed. Now, sample point spacing is how frequent the spacing occurs. U spans are the number of subdivisions in one direction, V spans in another direction. Stiffness is kind of important because actually, if we make the stiffness really low, you will notice that this surface kind of becomes very crinkly, and that's because it tries to stick to these points like more precisely. And what that means is that the area between that doesn't have any information regarding topography will become distorted, because what the surface tries to do is tries to interpolate them as precisely as it can, but the areas of no information becomes distorted. Now if we change this, if we make this a little bit bigger, the surface becomes less strict to following these points, but it becomes smoother. So we can crank this up to 8. Now the areas that I'm most concerned with are these kinds of sort of curves here. So you can kind of see the intersection between topography and the water. And if we were to kind of trim or split or intersect these are the kinds of curves that are going to occur. And I don't want that. I want the curve to run somewhere within the boundaries of these two. So I could mess around with these options, but I want to show you something else. So I'm going to just go ahead and click OK. So that's going to produce our surface. In fact, what I'm going to do is I'm going to actually create a ref point layer, and I'm just going to put all of my points on that layer. And with this surface, I'm going to create a new surface. Topo surface 1. I'm just going to put that surface on that layer. We can actually either we can turn the control points of the surface, and if we tap in points on, you can see that you can see these points here, which you can select and move, and that will change the topology of the surface. So you can now begin to manipulate the surface however you want. So if there's areas like it's just going to lock this water, it's going to get in the way. So we can actually manipulate these points here and make the surface lower or higher in specific areas, right? So it becomes completely manipulable. So if you have any kind of mistake, so you want the surface to be approximating to these curves a little bit better, you can use that technique. Now another thing that I wanted to do is I'm going to just create a new layer and show you just a different method of constructing these things. And this thing is going to involve the use of a plugin called Grasshopper. So it's a free plugin that you can get for Rhino. I believe the site is called Grasshopper3D.com. So if you go on that and you go to download page, it's free. And once you get it installed, you tap it into Rhino, and it will bring up this interface here. And if we just zoom it in a little bit, make it a little bit bigger. Now this is your palette. You can double click and bring in essentially Rhino objects like points and curves. We're just going to bring a simple point. And what we can do is if we can actually bring objects from Rhino into Grasshopper. We can bring objects from Grasshopper into Rhino. And what these objects are basically a series of commands that you can link in series. And I'm just going to show you a quick example of that. So if we are to select all the reference points, I'm just going to select all the objects. I'm going to right click on this component and go set multiple points. So now you can see that these things have turned red with little crosses on them, and when I click on it, it turns them green. So now these points exist in Grasshopper. It's going to deselect these, and as you can see, the Grasshopper points don't disappear. Just going to double click again and bring in patch. So you see this little battery pop up, and it has more outputs. More inputs. So on the left hand side we have our inputs, on the right hand side we have our outputs, and if we hover over these we can actually see what they want. So there's curves, there's points to patch, and exactly like what we did here. So this command takes in these parameters. So the primary one is either curves or points. So we've got points. As you kind of move closer to these little tabs, you'll see a little arrow appear. So what that means is you can actually click and drag an arrow out, and you can put it into any of these inputs. So I'm going to put it in the proper one, which is points. So you could put it in something else, and it might not be ideal because some inputs are the wrong inputs. So for instance, if you're putting an input which is a point into from an object which is a curve, so you're trying to match a curve to a point, it's not going to work. So you have to make sure that inputs correspond to outputs. And it looks like Grasshopper is actually having a problem with this. So yeah, it still worked, but obviously there's some kind of mistake. So in order to unplug this lead, what we can do is we can hover over any one of these, hold Control and drag it and put it back in again, and it actually deselects it. So when we select this patch command, we can actually see that the surface is being brought into Rhino. These additional ones are parameters that we can change. So for instance, double click this again, just type in any number and go enter, and it's going to bring up a number slider, which we can then plug into any of those parameters, and just simply by making it larger or smaller, we can actually manipulate the surface just by changing this number. I think there's a parameter similar to so this patch flexibility, so we can probably change that. That's probably going to affect, yep. So this gets us output very similar to what we got from the Rhino command. But as you can see, there's much more control that you can exert. If you double click on this and change it from integers to floating points, you see these decimals appear, and you get a finer control over what the surface is actually doing. So I'm just gonna kind of modify it until what I'm trying to get is for this intersection between this topographical surface and the water to be more or less within the boundaries of these two curves. So in order to bring this geometry back into Rhino, what we can do is we can click on the component, we right click, and we go bake, and we select the layer, and in this case I prepared this topo surface too, so I'm going to bake this to this layer, and it looks like it's not quite there. So I'm just going to double check this. So I'm going to unlock my water and quickly intersect these two surfaces. So I can select this surface, select that surface, quickly intersect them two, and we get a quick idea of how these two surfaces are intersecting. So obviously there is a problem there. So I can delete this, go back to my Grasshopper model, adjust it a little bit. That's looking pretty good. When you're happy, again, run the bake command, select the surface, and we get something like this. So now we can deselect these, can get rid of Grasshopper if you want to. I'm just going to work with this surface that I got from Grasshopper. So essentially it's very similar to the commands that we do in Rhinos, except it makes them parametric and kind of easier to control on the fly. The next step is to actually clean the surface up. So we got this surface that approximates these contours, but it's actually quite messy because it doesn't correspond to this side boundary that we've created. So what I'm going to do is I'm going to grab this curve, originally designated the boundary, and I'm going to extrude it both ways like this. And what I'm going to do is I'm going to use this box as a trimming boundary for this little bit that comes out. So if we type in trim, it asks us to select cutting objects, and I'm going to select this box as a cutting object. I'm going to click enter, select this, and it's going to trim this out like this. Just going to hide this for a second, and I'm going to do the exact same thing. Oops. Just going to type in trim to this surface here. So what I did was I used this water surface, the surface that represents our water level, to cut out our site. so it ends where water level is. So we get this kind of more or less neat site. Another thing we can do is we can trim out this from our actual water level, so do something like this as well. And another thing we can do is to use the topography and the water level hold on, let me just run the trim command again. Select the water level, select the topography, and then select this top bit of the box just to get this surface here. Now, I'm not sure why these contours have shown up. Let's just make sure they're on the right layer. Contours, yep. Just select them. Waterline. Okay, waterline was selected, so I just want to. Well, it looks like all this, we were drawing all this geometry on waterline, so I'm just going to quickly change that. Just going to put these layers on top of the surface, and it's very important to keep your layers organized so things are on the correct layers, because otherwise you just get confused with your own model. And if other people are working on this model, they might also get confused by what's happening. So now we have, let's see, waterline, dislikes. Okay, so now we have all these surfaces, which we can now join together. So they become joined. And we can cap the flat holes. So if we go cap, enter, it's going to put a surface where that planar hole was. Move face is another command. So if we tap that in, we can actually select a face on that poly surface, and we can move it around. If I deselect, project, so something like this, maybe move it a little bit further up, maybe like that. So we get a fairly neat kind of site model, like so. So I'm just going to make sure that there's nothing else in this model. Now, another thing you could do, as you can see, there's a road layer. So we can actually, if there are roads in your site, and you turn them on, they sort of approximate where this surface is, not quite, but we can bring them to this surface, right? So if we explode this, we can project these curves to this surface. So if we project, and we're asked to select the curves, and we select these curves, and we select the surface, and we press enter, and you can see that these rows have actually been projected to this surface. So you can use that to split away part of the surface that is enclosed by a road in order to put a different texture on it, or thicken it, or generate a curve or model curve. So there's it becomes quite useful because you won't be able to do anything with the surface with these curves because they don't intersect it, right? So that's a way of actually getting your curves to intersect with your surface. Now another thing is, I don't know if there's any buildings here. Looks like they're all very far away. So what I'm gonna do is I'm going to create an artificial building with a 3-point cube. I'm just going to create it here and move it over to the side, something like this. So let's say there's a building over here, and it kind of digs into the site a little bit, and at the moment they just intersecting each other, but they're not actually intersecting, right? They're just inside each other. You can make them intersect, and there's a number of ways to do that. So for instance, if you wanted both of them to become one object, you can use Boolean union. So if we do that, it asks us to select 2 B-reps, and when you press enter, you realize that now they're properly intersecting and they've become one object. Another way is to use Boolean difference. it asks us for the polysurface to subtract from, so that's our topography, and then we select our building, and we can, there's a delete input, so if that's switched to yes, it'll get rid of this box. If it's switched to no, it won't get rid of that box. When we press enter, we realize that it actually made a footprint. So if I hide this, this bit shows up as a footprint. This becomes quite useful if you want to do sections. So if we select this and we run a section, and we actually draw a section line through here, just drag this out a little bit, this footprint will show up in that section. Right, so that model then becomes quite useful. And if you're designing something that takes advantage of this slopey side, you might actually use some of these methods. I guess the last thing that I wanted to show, if you're generating a physical model out of this, another useful command is contour, and it does exactly what it sounds like. So you select your object, you press enter, you select direction of contouring. You can select X, Y, Z, or any kind of exotic direction. So if you select a horizontal direction, it will cut through the side horizontally, so like so. If you select vertical, it'll cut through it vertically, so it generates contours very similar to what we started with. And those could be used for things like, well, generating physical models out of this, or it could be used for diagramming. So this could create quite nice diagrams. So just a quick kind of tutorial. If we have this kind of geometry like this, and we select it, and we type in make 2D, and we go back to our origin in XY dimension, it generated lines out of that view.